Continuing with our post-VMSInstal steps, we'd like to set up and configure a typical interface. While we're at that, we're also going to enable I/O rates for that interface and configure shutdown events and check for crash command files. Our PINet node is equipped with a test program called Fractal. This isn't necessarily present on all PINet nodes, but ours happens to have it. Fractal is a simulation program or test program that generates data for Pi, and it works like or is designed to comply with OSI's standard for instrument and computer interfacing. So this test program Fractal has a point source, it has a startup command file we need to configure, and all the other features that you'd expect an interface to have. To begin, we might consult the documentation for the interface. Most of our documentation for interfaces has a section that describes installation and startup of the interface program. They may also have an installation checklist. So what you find in most of the interface documents is a brief description of one-line items necessary to start the interface, and then another section of the book that describes things in detail. This particular interface is fairly simple, so they skip the checklist and just provide the detailed instructions. To start the interface program, it looks like we need to have a command, something like this one here. And you can see we're running the Fractal program with a couple of parameters passed to it. The first parameter, the question mark, is the point source character, and the second parameter is an I/O rate counter. Interfaces may have more items on their command line than this, such as scan frequencies, ports if we're talking to a serial port, or other instrument system specific information. So it looks like I need to add something like this to the site-specific startup file for Pi. The site-specific startup file for Pi is called PINet site start, and there's a similar site stop.command file. Let's see how we set up the interface for startup. I might begin by editing my site-start.com file, and this is typical generic empty file, so I'll paste in some lines here. So what I've done here is I've used the lexical function $search to check and see if the file exists, and if the file does exist, then I'll get a fully qualified file specification back, including the expansion of this logical name. If I get a null back, not equal string null, then the thing won't exist. And if the file does exist, then I want to start up the interface, passing it the appropriate command line parameters, being the point source character and the I/O rate counter. So that's all I need to do here. Again, this if-then-else construct here was a little bit sophisticated. You don't have to do this. Merely typing in the command here would have been adequate, but my thought here was that if something happens to the Fractal interface in the future and it disappears, then I won't have a broken situation here. So I'll just save this, and we'll want to make a corresponding change to the site-specific shutdown file for Pi. You want to check the interface documentation. Most of our interfaces allow you to stop the interface merely by killing the program, and that's what this command file stop does for us. It asks the program to leave using an exit handler that the program may or may not be compiled with. If the program doesn't respond, then it's just killed. Most of our interfaces can be stopped safely in this particular fashion. Some of the interfaces, such as the Mod 300 interface, the Honeywell CM50 interface, they have a special shutdown procedure you must execute in order to cleanly and safely shut down the program. Fractal is one of those that fits in the majority case where you can just kill the program, and that's a safe thing to do. So I'll stop the Fractal interface by doing this. Putting the program name in quotes is optional. You may see examples where we've done this. Strictly speaking, it's not required, but if you want to be safe, it never hurts. So that'll take care of getting the Fractal interface started and stopped automatically. Next time we reboot Pi. If I wanted to at this point, I could execute the sitestart.com file to test to see that I can start the Fractal program. And I see Fractal running, and if I wanted to, I could execute the sitestop command file to test to make sure that I can shut the Fractal program down correctly. As I said, there may be more details to starting up an interface and configuring its startup file, and you should always check the interface documentation to be sure. I'd like to take a moment to talk about some more features involved in starting up one of the interfaces for Pi. I'd also like to introduce the idea of UniInt. I've logged into a different PINet node here that has a Fisher-Rosemount chip system. The chip system, we have an interface that we call chip2pi that runs on OpenVMS. It also happens to run, this particular interface happens to run on some other platforms as well. But we're going to limit our discussion here to the OpenVMS discussion. If I were to look at the PINet directory, I'd find a number of files whose name is chip2pi something. There's a chip2pi.com file which we're going to edit in a few moments, and we're going to see that it contains some command line parameters that we need to configure in order to set up the behavior of the interface. There's also a chip2pi-detach.com file. There's a chip2pi.exe, which is the executable that runs, and then you can see that we've run this interface a few times and there's logs that have been produced. The chip2pi-detach command file I sometimes refer to as a high-level command file. It's normally the command file you execute to start the interface. However, it's normally a file that you don't need to edit. You just run it. So the parameters and other items found in this file normally are appropriate as they ship from OSI. No changes required. I like to refer to the chip2pi command file as a low-level command file, and this is the command file that contains parameters in it that you're responsible for configuring and maintaining. This is considered a site-specific file, so it won't change on upgrade. If there are new features, you'll need to determine that from checking the PINet build directory after an upgrade and by reading the software release notes and the product documentation. Chip2pi is a command file, as I said, that you edit and maintain, but it's not a file that you normally would execute directly. Normally, to start and stop the interface, you would execute chip2pi-detach.com. chip2pi-detach.com is not a very long command file, and one of the things I might ask you to do is take a look at what's on the screen here and tell me the name of the program that actually executes when we try to start the interface. I'll give you a hint, this is a trick question. Well, looking at this, we see that there's a run detach command. So this looks like something that's going to run something. The rest of this is mostly just housekeeping and messaging. And what we see actually gets run by this is not the chip2pi program, but rather login out. This is the same program that runs when you walk up to a terminal and you bash on the return key a few times to get the system's attention, and the system responds by putting up a username prompt. What we're in essence doing is we're creating a separate instance of the VMS command shell by running the login out program, and instead of prompting for username and password, we're running this in the background, the detach switch. And instead of executing a login.com file to start up this new session, we're executing an input file called chip2pi. So this is where the configured parameters that you set go. And rather than direct the output to a screen and interact with a keyboard, we're redirecting the output to a log file, and this is how the log gets generated. But the key thing to note here is we're not running the interface, we're running login out to create a new command shell or command interpreter to execute the interface within. The reason we do this is partly so that VMS keeps better track of the interface program and keeps accounting and other troubleshooting and debug information. The other reason for doing this is so that the interface program is not dependent on a parent process for resources. So rather than become a child of the program that launches this, when we run the interface in this manner, it's independent and stands on its own. So those are the reasons why we do it this way. If we take a look at chip to Pi, we'll see that this is an even briefer command file, and the catch here is that it's got a command line with a bunch of command line switches. The syntax here is quite a bit different than what we saw with Fractal, and this is partly due to the fact that this is a UniInt based program. So in the next lesson we'll talk about the UniInt features specifically. In the earlier lesson I mentioned that some of our interfaces are based on something called UniInt. OSI has a set of reusable code that we use as the starting point for many of our interface developments, and we call this UniInt. UniInt provides many common functions that an interface needs to support, such as the implementation of a point source, reporting of status and performance through event counters and performance points, scan frequencies, and so on. If we take a look at the interface documentation for the chip to Pi interface, we find a section that details command line parameters which are entered into the chip2pi.com file. Each of the UniInt based interfaces will have a slightly different list of command line parameters, but many of the command line parameters are similar due to the nature of the UniInt. So there's a debug option. If I scroll down here, there's a snapshotting option, point source option, an ID option. There's an event counter option that we'll find here, scan frequencies. And you can learn more about the generic options of the UniInt interface and the specific options of the interface by looking at a document on your Pi documentation CD called the UniInt End User Manual. Taking a look at our chip to Pi example here, we can see that one of the differences we see here versus the Fractal program we were looking at is that there's a slash used to separate the items on the command line. So in the Fractal program we were using spaces, and some of the other Pi interfaces use commas to separate the items on the command line. Also, that the items on the command line with the UniInt interface are prompted. So there's a 1 or 2 or more character long prompt that identifies the parameter to follow. So I have PS for point source, I have EC for event counter, I have F equals for scan frequency, and I can have more than one scan frequency here, ID number for the interface number, and so on. So this is characteristic of UniInt based interface. Most of the UniInt interfaces support point source, event counter, scan frequencies, ID number, also such things as snapshotting SN. So you want to set those up for each of your interfaces, and your guideline for doing so will be the documentation for the interface program. Again, there'll be a section that talks about the command line parameters or the startup file, and that's how you'll find those settings.